This is David Spears, Civil Engineering Instructor at Texas Tech University, talking about CE 2301 statics. We've got an interesting 3D equilibrium problem involving three bars instead of cables. And so we're trying to find the magnitude and the sense of the force in each one of those three bars, AD, BD, and CD. Because they're bars, they can carry tension or compression, which just adds another element of interest to this problem. Other than that, it's kind of like a cable problem. I've given the coordinates of the endpoints of the bars, including point D, where all three bars are attached with some sort of ball and socket joint that can kind of swivel. And then I've got the applied force of 750 pounds straight down, like it's a weight. So first thing I want to do is show a free body diagram. And it's pretty simple. I've just got my applied force of 750 pounds down, and then the forces in the bars, FAD, FBD, and FCD, which for this purpose I would assume as being in tension. So they're pulling away from point D. And then I'll let the signs of my answers tell me whether or not it is in tension, or if I get a negative sign, I'll know that bar is in compression. We'll see that later on. First thing I want to do is express the forces as Cartesian, and I'll kind of do this first one in detail, and then do the second and third a little more faster and simpler. First, I kind of want to draw a position vector from D to A, so I would call it RA over D, tip over tail. So I subtract the coordinates of the tail from the tip coordinates. So that's 4 minus 0, negative 4 minus 7, and so on, showing it up here. 4 minus 0, negative 4 minus 7, J, 0 minus 4, K. That's just these coordinates minus these coordinates. Do the math. Then I want to get the length of that position vector as a square root of the sum of the squares. That works out to be the square root of 153, or 12.37 feet. All my units are in feet, my dimensions. Then, remember, I want to get a unit vector, which is unit vector length 1, which these are really just the direction cosines of that vector. 0.323i, I just divide the position vector in Cartesian by its length, and I get 0.323i minus 0.889j minus 0.323k. Then I can express vector AD, FAD, as the magnitude of it times the unit vector. So it's 0.323 FADI, and so forth. Then, kind of a simpler, quicker way of doing FBD is just to write it out like this. Write my position vector here, write my length of my position vector here, do the math, and I come out with FBD vector expressed as this Cartesian form with these components. Remember, these are the direction cosines. I can take the inverse cosine of that number and get the direction angle alpha, the vector to the x-axis, and so forth for beta and gamma. Just a little review. Do the same thing for the vector FCD, position vector divided by its length, Cartesian components, which are the direction cosines, which are really also the components of the unit vector in that direction. There's different ways of expressing things. Finally, I'll have my applied force, which is 750 pounds F, which is that vector, which I could express as Cartesian as 0i plus 0j minus 750k, because it's directed down, so it's negative 750k. Now I've got everything I need to start solving equations. I've got three equations that I can apply to this. Sum of forces in the x, sum of forces in the y, sum of forces in the z. They're all equal to 0 because we're at equilibrium, because this is statics. So what I'm really going to do is combine the terms I've kind of written in columns over here. These are all my I or X terms. These are my J or Y terms. These are my K or Z terms. So starting with the X, first I want to note that, so I'm going to end up with 3 equations, 3 unknowns. I kind of want to make my last one, this one where I have a known value, the sum of forces in the Z, because I know that number, 750. These others are just equal to 0. So you'll see how this works out to be the one I kind of want to save for last. So I start off with sum of forces in the X, and I've got these 3 components: 323 FAD, negative 456 FBD, and 570 FCD. So I write that out as an equation here, observing my negatives and positives. 0.323 FAD minus 0.456, because that's that value, plus 0.570 FCD. That's all equal to 0. So I think it's useful. We're dealing with a jillion multiplications and additions, so you really want to try to keep it. I've tried to jumble it all here. It looks jumbled, but I've kind of organized it. On your paper, you want to be organized and logical and make your calculations so you can follow them and write clearly. So I've expressed that sum of forces in the X, combine that column. Then I can rearrange it and I can say 0.323 FAD is equal to these other 2. Take them to the other side of the equal sign. 0.456 FBD and negative 570 FCD. Then I can divide both sides by 0.323 and I can get FAD is that expression divided by the 0.323. Do the math, and I can say FAD is equal to 1.41 FBD minus 1.764 FCD. Now I've got FAD in terms of the other 2. I can go to my next equation, sum of forces in the Y, which I just combine that column, write it all out horizontally. I can get, my first term is negative 0.889 FAD. Well, here I want to substitute this value for FAD into there, and negative 0.889 times this expression, and keep these other 2 for FBD and FCD. Do all the math. I end up with, when I multiply this out, that wasn't good, negative 1.25 FBD plus 1.57 FCD, that's just this number times these 2 numbers, minus those 2 components, FBD and FCD. Combine the common terms and I get negative 2.09 FBD plus 1.114 FCD. Then I can rearrange that and get the, that's FBD. I can get FBD is equal to this divided by 2.09, because I've taken this to the other side of the equal sign, so I've got all positives. 0.533 FCD. Now I've got FAD is equal to this and FBD is equal to this, FCD in terms of times 0.533. Now I can go to my sum of forces in the Z, so I've just gone to this column here and I've added these 4 components, just expressed it out horizontally. I get this expression, but I know that FAD is equal to this expression. I go back up to here, 1.41 FBD minus 1.764 CD. But I know that FBD is equal to 0.533 FCD. And so I can substitute that in for there, and I get this expression, which I can then simplify out to FAD is equal to 1.012 FCD. So I can plug that into here. I've taken my 750 and put it on the other side of the equal sign, just because I was running out of space. So I've put that value for FAD in terms of FCD right here, and I've taken this value for FBD in terms of FCD and put it in here. Done the math. 750 is equal to this times FCD this times FCD minus this times FCD. Combine all those terms, negative 519 FCD is equal to 750. So therefore FCD is just equal to 750 divided by negative 0.519. Got to be careful about keeping my negative signs in there, which works out to be negative 1445 pounds. The negative tells me that my sign assumption up here for CD is positive. I assumed it was going tension in that direction. It's really going negative that direction. So it's compression. I assume tension. I got a negative sign. That meant I have compression. Then I'm almost home free. Look at FBD, which I've got up here. Substitute in the value I got for FCD. Remember, it's negative. So FBD works out to be negative 770 pounds. Once again, the negative sign means my assumption of tension up here in my free body diagram was wrong, or just backwards. And I get 770 pounds compression. Finally, FAD, go back up to this expression right here where I solve for it just in terms of FCD. Plug in the numbers. I get 1462 positive, which means it is in tension, like I assumed it. And so I report that as that answer. Now anytime I have a chance to, I've done a zillion calculations and I want to check my math, because I will tell you the first time I worked this out and drew this out on this board, I wrote down that number as 553. And when I got to the end, I saw that I had like 1404, something like that for this. Well, I plugged it into this equation. I got my numbers, and I plugged it into this sum of forces in the z direction equation, right there in blue, and I didn't get 0. So, having all this written out, I was able to look back, and it took me 5 minutes, but I backtracked and I found that I wrote 553 instead of 533. So I knew that I had, well, then I had to rework several numbers down here in the last part. So what I would recommend is, on a test or homework, whatever if you have time, which you probably will, plug these numbers back into one of your equations, earlier equations, and see if you've made a math error. So if I get the right numbers in here, plug them back in there for FAD, FBD, and FCD, that all comes out to be 0.38, which with all these big numbers is close enough to 0. I've got a little bit of rounding here.